Okay, in Unit 5, what we're going to be going through is electricity and electrical circuits. The first activity is labeled simple and mixed circuits. This is just background to get us on to U5A2 and U5A3. So I would suggest that if you do anything beyond going through the content, take a look at some Khan Academies on amps, volts, and resistance. We're also going to be looking at some simple circuits in this activity. So electrical current, also called amperage, here's the symbol for amperage. It's a capital I, equals 4 amps, just the way it's written out. There's nothing specific about the 4. I'm just showing you an example of how it's written out, is the flow of electrons. So it's the number of electrons to pass a specific point per second. Now, one place where you get confusion is the flow of electricity. Electricity goes from the negative terminal to the positive terminal. Because electrons are negative, they're attracted to the positive terminal. Here's the issue. When they originally started talking about electrical circuits, what happened was they thought that electricity flew in the opposite direction. If you ever talk about conventional current, they will say that the current flows from positive to negative. This is not true. This does not happen. I'm going to try and correct this every time I see it. Now, just talking about electrical current, we can talk about direct and alternating current. Direct current, an example here would be batteries, and basically that is just the flow from the negative terminal to the positive terminal. In alternating current, what happens is the electrons are vibrating at a very high frequency as they travel. You'll find AC, or the alternating current, in wall sockets. And it's safer, it's easier to transport electricity in this form, and it's also easier to transform it. So what we can do is we can change the voltage of the AC electricity much easier than we can with the DC. There's less moving parts in an AC motor, and therefore it's also cheaper. So a second term that we're going to see besides current is voltage. Voltage is a common term. Physicists use the term electric potential difference because what happens is each one of these electrons in the current can either up their energy or down their energy as they go through the circuit. So you get a rise in energy as you go through a battery. So an electron can gain energy and go up from 0 volts to 9 volts, for an example. Once we go through a load, there's a drop in potential energy. So as current moves throughout a circuit, we have a total drop of the voltage as we go through that circuit. Resistance, you'll hear the term ohms there, or you'll see the Greek symbol omega, stops the flow of electrons in a system. So things that affect the electron flow: wire length will increase the resistance. Wire thickness, the thinner the wire, so a thicker wire will have less resistance. If you're having trouble picturing resistance, think of it this way. If you have a hallway, picture yourself walking down that hallway at a school. Now, throw a bunch of students in that hallway. You have more resistance. It's tougher for you to get through. So if the wire is thicker, it's easier. So the wire or the hallway is wider. If the hallway is thinner, it's harder to get through. So wire length. Longer wires are harder to get through. Wire temperature, harder to get through. Type of material can also affect the resistance. What you should do is you should go through all the parts that make up a circuit as you go through U5A1 and make sure that you understand what some of those parts are. So for a load like a light bulb, I just draw something that looks like that, and then I put a circle around it. So a load is anything that uses up voltage as the electricity passes through it. So when we go through any type of resistor or load, what happens is we have a transformation of electricity. In other words, the electricity can be converted to light in a light bulb, or heat in an old-fashioned light bulb, or in a fan, it can be converted into motion. This is what a resistor looks like. Sometimes we add resistors into systems to change the voltage. If you ever draw a voltmeter when you're in a circuit, it must go around a load of some type. So it must be in parallel. Where an ammeter measuring amps goes right in series within the circuit. If this is a battery, well, actually one of these is called a cell. It's called a battery when you have many of them together. So in a flashlight, if your flashlight takes batteries, you would put in one cell and then you'd put in two cells. When you have more than one cell, you have a battery. This is the positive terminal, the bigger one. This is the negative, positive, negative. So this is how we would draw two cells or a battery together. So if these were each 2 volts, we would have 4 volts all together. So this is a battery. We've got a wire right here, and here we have a switch. This is the switch open. So this circuit would not be working right now because to be working, this switch would have to be closed so that we make a full connection. Make sure you understand the parts of a circuit. Next thing, let's do a circuit in series. So we go from negative to positive. What makes this in series is all the loads are on the same circuit so that they're all on the same route going through. So if you go through one load, you go through the next. This one is parallel. So we've got a light bulb on one circuit, and then we've got another light bulb on another circuit. So this is series, and this is parallel. Take a look at some circuits and this drawing of some circuits before you move on to activity 2.